I'm Professor Mark Maslin, and I'm a Professor of Paleoclimatology at University College London. What that means is I study old climates. And I'm particularly interested in how East Africa has changed over the last 10 million years and became the hotbed of evolution, particularly for humans. The most important thing to realise about East Africa is everything has changed in both the relief, the topography and the climate over the last 10 million years. If we were here 10 million years ago, then it would have been a nice flat area with beautiful moist forests. Since then, everything's changed. You have huge rifting. And rifting is when you have a hot bit of the magma coming up, and it pushes up the crust, it domes up, and just like your mother's apple pie, the crust splits, and what you get is two big mountain ranges running along East Africa, and in the middle, a valley which actually hangs much higher than sea level than you would expect. So you have a huge mountain range, which then fragments the whole of the environments. Instead of having just one blanket forest, you have all these different environments. On top of that then, climate changes. And so over the last sort of 60 million years, global climate has been slowly cooling, mainly driven by tectonics, the movement of the plates around the world. Key to that are some of the big steps. So about 2.5 million years ago, suddenly we hit a threshold and the big ice sheets start growing in North America and Europe. We're talking about 2 kilometers of ice over Chicago every ice age. After that, we shift slowly forward, and about 2 million years later, or 2 million years ago, then suddenly the tropics change. And here, this is something that we hadn't realized until very recently, that the atmosphere circulates east to west in the tropics, bringing moisture onto Africa, into the Amazon, and into Indonesia and Southeast Asia. And the key thing about that is about 2 million years ago, this circulation intensifies, it speeds up, bringing more extreme weather to these parts of the tropics. And then we end up about 1 million years ago, and these beautiful ice ages that have been every 41,000 years suddenly switch and become a lot longer and deeper, taking maybe 80 to 120,000 years, and then an incredibly sharp exit called a deglaciation. And that's the backdrop to actually African climate. And for me, the most important thing is studying the lakes, because here you can actually go out as a geologist. You can take samples of ancient lakes and find out when they occurred, how deep they were, how fresh they were. And this, I feel, is actually the backdrop for human evolution. Because we can see that there are distinct pulses when these lakes suddenly appear, fill up the whole Rift Valley, and then vanish. And it's that changing environment, these pulses, that actually we think may have driven this evolution in this area. And for me, that and understanding the environment, how those lakes, how those water actually infect and increase the environmental variability, and how that influences how our species develop, I think is really important. For me, finding out that actually we were born in climate change to deal with climate change is actually a really optimistic feeling, because it means that if our brain is developed to deal with this sort of environmental change, it means that we have hope for the future with global climate change.